Good morning, learners. Today we are going to be talking about transmission media. By the end of this topic, you will need to be able to explain, or you should be able to explain, the benefits and drawbacks of using copper cable, fiber optic cabling, radio waves, microwaves, and satellite technology or media. Right. Transmission media, divided into two parts. Basically, what is transmission media? This is the media or the technology that is used to connect devices uh, at a distance, basically. Yeah, so these devices need to be connected, and we use transmission media to connect these devices to allow for the transmission of data from one device to another. Right, transmission media is divided into two parts. You have your guided media and you have your unguided media. Guided media is basically your copper cables, your fiber optic cables, and so on. Copper cables are divided into two parts. You have your coaxial cables and you have your twisted pair cables. Twisted pair is also divided into two parts, where you have shielded and unshielded. Coaxial has baseband and broadband. I'm going to look at all this further along the presentation. We have unguided media. This is where there are no cables involved. Basically, we are looking at a device connecting to another device wirelessly, and these are divided into three parts. This is your radio transmission, microwave, and infrared, which is not here, but it will be explained as we move along. Right, terminologies that we should know. Basically, when we talk about this transmission, there is speeds and interference and so on that can cause for transmission to change, and so on. First one there is bit rate. It is the number of bits transmitted per second between the sender and the receiver, measured in megabytes per second or megabits per second, gigabytes per second or gigabits per second, and we'll explain later on what the difference is. And we have baud rate. It is another measurement of transfer speed, which looks at the number of state change per second. Basically, transmission or the speeds of internet, or not internet, the speeds of data transfer can change depending on the distance you are away from your device, or the sender is the distance between the sender and the receiver. The further you are, the slower the speed, or the speed will basically change, and that change is now called the baud rate. How often does it change? Basically, it's measured using baud rate. Then if we go further and we talk about twisted pair cables, we have two types, shielded and unshielded, and this is a diagram of how it looks like. And this is mostly used in local area networks. Coaxial cable is used by television companies. This is connect to your decoder and your satellite. Fiber optic cables, light signal traveling via a fiber optic cable are immune from electromagnetic interference and radio frequency interference. Okay, this is just one of the examples. You use these cables over extremely long distances. Right, and factors to consider when acquiring transmission media: we have to look at cost, bandwidth, attenuation, interference, and the need for repeaters. These are the things that we're going to look at when we look at our transfer media before purchasing one. Right, the costs. In this situation, fiber optic cable is the most expensive one compared to twisted pair, and so twisted pair wins this round. Then we have twisted pair. We have bandwidth. Bandwidth is a measure of the space of communication channel. Basically, how big or how much data can we transfer between or while using one of these transmission medias. Basically, it has the possible range and the frequency that data can travel along. A larger range of frequency allows more data to be sent per second, measured in hertz or megahertz. Okay, now fiber optic will obviously be the highest, but in order for us to actually understand, I've uploaded this video here so that we can actually get a detailed explanation for bandwidth.
Hello and welcome to Science Everywhere. Bandwidth. We have heard this term, but what does it mean? Computers use the binary language of ones and zeros to communicate with each other. These signals of ones and zeros are transmitted as electric pulses. A high pulse indicates a 1, while a low pulse indicates a 0. Coming back to the original question of bandwidth, bandwidth is the frequency range over which a signal spans itself. Such type of bandwidth is measured in a unit known as hertz. Bandwidth can also be defined as the data transmitted per unit time, which is measured in bits per second or megabits per second. One important thing to be noted about bandwidth is that as it increases, the speed of your connection also increases. Here you may ask that why can't we increase the bandwidth of our connection infinitely so as to get an infinite speed? Well, wait a second, there's a catch. Bandwidth is not just directly related to the speed, it is also inversely related to the range. Hence, as the bandwidth increases, the range decreases. Hence, just in case you have a Wi-Fi router with a higher bandwidth, you may have a higher speed of connection, but the range of the connection will be low. The electromagnetic band in the bandwidth can be used in two different ways, namely baseband and broadband. You may have heard these terms, but what do they mean? Baseband, which is used in Ethernet connections, uses the whole band to transmit just one signal of information, whereas broadband, which is used in TVs, transmits a number of signals through the whole band. Another differentiating property is that baseband allows you to either send or receive a signal, but not both at the same time, whereas broadband allows you to send as well as receive the signals both at the same time. But when do we use each of these? The usage depends on the conditions for transmission. Baseband uses very low frequency waves which can deteriorate over long distances. Hence, they are used for short distance communications like communications over a local area network or LAN like Ethernet. Broadband, on the other hand, uses very high frequency waves to transmit the information signal. Such waves can travel over long distances very easily. Hence, a broadband connection is used in long distance communication devices like television sets or radio sets. So, now you know what the megabits per second speed of your internet connection means, and you also know the various types of band usages and where they are used. Thanks for watching Science Everywhere. If you learned something new, give this video a like and also...
Right. Hope that makes sense. Talking about bandwidth. Yeah, twisted pair, the lowest. It's got the lowest bandwidth. So we do not really want to opt for that because the speed is going to be very slow. And when we talk about fiber optic cable, it's actually not the speed, it's the amount of data that you can send over a specific period or per second, basically. In a second, twisted pair would obviously send less data compared to fiber optic cable. Okay, then we spoke about, or we mentioned also attenuation. We should look at attenuation, and which one is most affected. That would be your twisted pair. So in this round, fiber optic wins this one because fiber optic does not suffer from attenuation. What is this attenuation? helpful. Now we know what attenuation is. Basically, the main thing that I can really think about or get from that is the distance. Further you go, the poorer the signal, basically, is what we said. So it will make it difficult for information to be transferred, or it will be transferred at a very slow rate. Now, which cable is most affected? That is now your twisted pair, as usual. And then your fiber optic cable is actually the least one. So fiber optic cable wins this round. Then we talk about interference. This is anything which modifies or disrupts a signal as it travels along a channel between a source and a receiver. So anything that disrupts. So we're taking disrupts or modifies, and we're talking about when in IG we spoke about parity checks and ARQ and all these type of things. Basically, when we talked about transmission, we also spoke about errors in transmission. Errors in transmission, basically interference. We're talking about ones changing to zeros and zeros changing to ones and so on during transfers because of electromagnetic waves and radio frequency waves. Yeah, or radio frequency interference, electromagnetic interference. And in this case, twisted pair is the worst affected. So again, fiber optic cable wins this round because there are least interferences with fiber optic. And remember, we mentioned that fiber optic is immune to electromagnetic interference. Right. Then wireless technology. We're talking about it's wireless technology is an alternative to cables in a wireless transmission, namely radio, microwave, or infrared. And the difference is frequency or wave. That is the difference between the different waves. It's the frequency. If you look at these technologies, I've just given just a few examples there. Infrared, basically a remote control. Also, Bluetooth is also using, it's basically using radio frequencies. And then we have some other couple of examples there, like satellites are also using, but they're using, I think, microwaves and so on. And we have Wi-Fi as well, which is also, but depends on the frequency. So if the frequency is falling between 3 kilohertz to 3 gigahertz, then it's falling under radio. And then 3 to 300 gigahertz, that falls under microwaves. And then when we talk about 300 gigahertz to 400 terahertz, then we're looking at infrared. And in this situation, we look at the bandwidth. We spoke about bandwidth already. We know how much data is traveled or is sent. That's basically what we're talking about in a given second. And in this situation, infrared wins that round because infrared sends more data over their wireless technology. And that radio would be lowest. Attenuation, we spoke about attenuation, distance, the further you go. That means which one is mostly affected. Infrared is the most affected, which means radio frequency will win this round because it is not really affected like infrared. It is also affected, but it's at a greater distance. You can go a greater distance and still get a good signal, but the further you go with infrared, the less you'll be able to be connected to a device. Then the need for repeaters. Yes, infrared is needing more repeaters compared to radio frequency. Therefore, radio frequency wins that round. They don't need so many repeaters. Directional focus capabilities. Infrared will win this round because of the directional focusing. And then penetration through a wall. Radio frequency would win this round because they have a higher chance of going through the wall than infrared. Okay, so according to these frequencies, do your research, find out from the different routers and tell me where Wi-Fi falls in. Does it fall under radio frequency? Does it fall under microwave, or does it fall under infrared? And if you do that, then you can also check for me Bluetooth and Remember, the frequencies are always provided when you do your research. Right. Let's hear what they have to say about infrared.
Created using Powtoon.
Right. Hope that was helpful. Then we talk about wireless interference.
Battling for Wi-Fi connectivity? Welcome to Wi-Fi 101. Does your wireless network seem slow? You've probably heard that some household electronic devices, including microwave ovens, baby monitors, and cordless phones, hamper Wi-Fi performance. Things to consider. Your neighbor's Wi-Fi network. If you use a 2.4 GHz router and live in a densely populated area, your neighbor's Wi-Fi networks could interfere with yours, hindering the performance and range of your wireless network. Household electronics. Is your microwave oven, cordless phone, or baby monitor sabotaging your Netflix stream? Perhaps. Most problems with cordless phones and microwaves involve products that use a 2.4 GHz band. Many baby monitors operate at 2.4 GHz, which can interfere with routers. It's important to get a router that supports simultaneous 2.4 and 5 GHz. Think twice about putting a router somewhere with a lot of people. Water inhibits Wi-Fi signals. Since humans are mostly water, a bunch of us hanging out in a room together can interfere with the signal. You may have noticed getting worse internet connections in crowded spaces. And yes, you probably want a good Wi-Fi signal in the room where people like to gather, but all those bodies might slow it down in other parts of the house. Have more questions about getting the most out of your Wi-Fi? The experts at YK are here to help. Class dismissed.
Outstanding. Interesting. Yes, now to just conclude, examples of a real life situation. I'm going to be looking at telecom transferring data over 50 kilometers, for instance. And then just quick brush over the wireless media. Which device would be suitable when transferring a fiber optic, when transferring data over 50 kilometers between now fiber optic cable or copper cable? I would say that fiber optic cable would have a greater bandwidth. That's what we've learned from the lesson. Fiber optic cable needs less signal boosting, meaning no repeaters basically over long distances. Fiber optic cables are immune to electromagnetic. We mentioned that already. They cannot affect, so no interference in that regard. And then fiber optic cables consume less power as well. This is just one the bonuses of fiber optic cables. Okay, then copper cable. Copper cabling is less expensive. Copper cable is easier to install because it is flexible. It's easier to make terminations using copper cabling. um, the expertise in use of copper cabling is more extensive. Right, so at the end of the day, you still need to choose which one and always give your 4 reasons or 5 reasons, whatever the question is required in the examination. Which can be the best, radio frequency or infrared? Before you can decide, you need to decide which situation. If you are looking at wireless technologies, to give given examples there, maritime radio navigation, maritime radio navigation. You can see there the frequency or the distance, and then the frequency that is required there. We're talking about 3 kilohertz to 30 or 300 kilohertz. And I'm pretty sure, if you remember correctly, there is a frequency which is radio, basically, that you will need to use in this scenario. And the bigger it gets, say for instance 3 gigahertz there going up, and we're looking at Wi-Fi and so on. And then you see there you're talking about television and mobile phones and GPS, Wi-Fi, 4G. All these technologies are using microwaves or radio waves. Yeah, so it's up to you to determine which one is which, and you will need your table that indicates which frequency is or which one is used there. We're looking at radio, microwave, or infrared. Right, thank you very much. I hope you enjoyed the lesson. If there are more questions, please don't hesitate to ask.